Okay, welcome back to another video on the Maths channel. It's your teacher, Miss Lim here, and in this video we're going to be looking at Lesson 3, Reciprocal Functions. So by the end of this lesson, you'll be able to use the graph of y equals f of x to graph its reciprocal, y equals 1 over f of x. So here's some key notes. 1 divided by 0 is not possible, so we'll get a vertical asymptote. 1 over 1 is 1. 1 over minus 1 is minus 1. 1 over something positive is a positive answer. 1 over negative is a negative answer. 1 divided by something really big will give us a really small answer. And 1 divided by something really small will give us a really big answer. So let's have a look at some examples. Find the reciprocal of 4, minus 3, 0, 2 over 5, and minus 7 on 6. Maybe you pause the video and have a go with these yourselves. So we can rewrite 4 as a fraction as 4 over 1. So the reciprocal of that will be 1/4. We can do the same thing for minus 3. Minus 3 is minus 3 over 1. So the reciprocal of that will be negative 1/3. 0, we can write it as 0 over 1, and the reciprocal of that is 1 over 0. Oh wait, that's not possible. We're not allowed to divide by 0. We'll get a math error. So this would be a vertical asymptote. Question D, 2 over 5, reciprocal is just 5 over 2. And for E, the reciprocal of negative 7 over 6 is negative 6 over 7. Alright, so now that we've got a good idea of how to find a reciprocal, it's just flipping the fraction, or 1 divided by the value, we can apply this to actual examples. So we're going to sketch the the reciprocal of f of x, for f of x is equal to x minus 2. So what we need to do is we need to graph this f of x, and once we've done that, we can then draw the reciprocal function. So I'm going to get my axes. We know that x minus 2 is a straight line with a y-intercept of minus 2. So I'll just write that, minus 2. And we know that it's got a gradient of 1, which means rise over run will be 1. So it's going to have an x-intercept of 2. And so now I'm just going to draw my straight line that goes through those 2 points. Alright, so that's f of x is equal to x minus 2. Now that we've done that, we can actually sketch the reciprocal function, f of x to the minus 1. Now, up here, I said, look at these keynotes. And all of these values down here that we are looking at, all the ones that we're doing 1 divided by, we are looking at the y value, not the x value, the y value. So when the y value is 0, which means an x-intercept, there'll be a vertical asymptote. When the y value is 1, the reciprocal will be 1. When the y value is negative 1, the reciprocal will be negative 1. Okay? So let's have a look at this one here. The y value of this point right here is 0, right? This is technically 2, 0. So the y value is 0. That means that 1 divided by 0 is not possible. There will be a vertical asymptote at x equals 2. Okay, so there's a vertical asymptote there. The next thing we're going to do is we're going to have a look at minus 1 and 1. Because we know that 1 divided by 1 is just 1, and 1 divided by minus 1 is minus 1. So wherever along this line it has a y value of 1, which is right here, the reciprocal will also be 1, which means that the reciprocal function will go through this point. This one here, y value of minus 1, is over here, which means 1 divided by minus 1 is also minus 1, so the reciprocal function will also go through this point here. Alright, the next things we're going to have a look at is up here. 1 divided by something really big is really small, and 1 divided by something really small is really big. This point here just tells us that when we draw the reciprocal function, it will never ever actually cross the x-axis. There will never be an x-intercept. Okay? So if we have a look at this portion of the line, can you see how the y values are really small? Right? It's really close to 0. 1 divided by something really small is really big. It's going to be really big. And over here, like it goes up to infinity, 1 divided by something really big is really small. It's going to be down here. And so we can see here that when we graph this, it's going to look something like this. That's that part. And then we've got this part here. This part here of the graph of f of x is really small. It's really close to 0. And 1 divided by something really small is really big, except this is really big in the negative direction. Because remember, it will never cross the x-axis. And over here, it's really big in the negative direction, and 1 divided by something really big is really small. Right? It's really small. So I know it's going to go like this, but there's one more important feature, and that's the y-intercept. Because the y-intercept of f of x is -2, or technically -2/1, the reciprocal of that will be -half. So that tells me I know that this portion of the graph of the reciprocal function is going to go through that point as well. So now I can graph the rest of this. And that's it. I have sketched the reciprocal of f of x. Alright, let's have a look at question B. Sketch the reciprocal function 1 over f of x for the graph y equals f of x below. So the first thing I need to do is I want to look for all the y values of 0. Maybe I'll just write this down as a list. Look for when y is equal to 0, because 1 divided by 0 is not possible. We'll get a vertical asymptote. So they are all my x-intercepts, right here, here, and here. I've got 3 x-intercepts, meaning I've got 3 asymptotes. Oops. Right. The next thing I'm going to do is I'm going to look for when y is equal to 1. So here's y equals 1, and here's y equals -1. I might write that down as well. 1 and -1. And so I can look across, I can see the reciprocal function is going to go through here, and through here. And for -1, I can see that it goes through here, here, and here. So I know the reciprocal function will go through those points. Alright, the next thing I'll do is I'll look for the y-intercept. Now the y-intercept is here is 0, so that's, I don't really need to worry about that. And then some other key features, such as turning points. So here the turning point has a y value of 2, so that means 2 over 1. So the reciprocal of 2 over 1 is technically half. So at x equals -3, it's going to go through half. Alright, and there's another turning point over here. When x is 3, y is -2, or -2 over 1, and the reciprocal of that is -half, which means that the reciprocal function will go through 3 minus half. Alright, so now we've got everything we need to graph the reciprocal function. 1 divided by something really small is really big, but remember this is negative, so it's going to be negative. 1 divided by something really big, it will be really small. So it's going to give us something like this. Alright. 1 divided by something really small, because it's really close to 0, it's really big up here. All right. 1 divided by something really small is really big, just in a negative direction. And 1 divided by something really small, because very close to 0, is really big. And that's it. It's going to look something like that. Okay. Let's have a look at question C. Sketch f of x to the minus 1 for the graph y equals f of x below. So we can see here, first thing we do is look for when y is equal to 0. The x-intercepts here, so there's a vertical asymptote at x equals 0. Second thing we do, when y equals plus and minus 1. When y is 1, it's going to go through that point. When x is minus 1, going to go through this point. Okay. Number 3, y-intercept. Y-intercept is at 0, so that doesn't really matter because we've got a vertical asymptote there. And number 4, any key features that we can see before we graph? Oh, we see that there are asymptotes at y equals 2 and y equals minus 2. Well, that's 2 over 1, which is, the reciprocal of that is half. So that means there's going to be an asymptote at y equals half. So I'm going to put that asymptote in. Oh, there's an asymptote at minus 2 as well, or minus 2 over 1. So the reciprocal of that will be negative half. So we're going to draw in our asymptote here for the reciprocal function. Okay, now that we've done that, let's have a look at different portions of this graph f of x. This bit here, really close to 0. The y values are really close to 0. And 1 divided by something really small is really big. So it's going to be up here. What about, just get rid of that. What about this portion? Really close to 0 as well, just in a negative direction. 1 divided by something really small is really big. So, really big in a negative direction down here. And so now we've got enough to graph. Just remember, it's not going to pass through that asymptote. And same with this one. Right, there's an asymptote here, so we need to make sure we do not go through it. Done. Right, question D. Sketch a graph of y equals 1 over f of x if f of x is equal to x squared plus 2x minus 3, and find its domain and range. So, the first thing we need to do is sketch this. Once we've got f of x, the graph of it, we can then easily work out what the graph of 1 over f of x will look like. So, let's get my axes. We know f of x, that's a monic, and that will factorize x plus 3, x minus 1. So that tells me we've got x-intercepts at minus 3 and 1. We have a y-intercept at minus 3, because when x is 0, y is minus 3. And our turning point, the x-coordinate is equal to minus b over 2a. So we're going to look back at this fully expanded equation. Minus b will be minus 2 over 2 lots of a, which is just minus 1. So when x is minus 1, y is going to equal to minus 1 squared plus 2 lots of minus 1 minus 3. So let's just put that in the calculator. S is squared plus 2s minus 3 minus 4. So we know that the turning point will be at minus 1 minus 4. Over here. Alright, so that's enough. Let's graph this. Parabola. Okay, so this is f of x. So if we want to work out 1 over f of x, we can now look at when y is equal to 0, the y values, the x-intercepts, over here and over here. We can now look at when y is equal to 1 and plus and minus 1. 1 is here, minus 1 is here. So over here, over here, over here, and over here. Alright, the y-intercept. Well, the y-intercept here is at minus 3. So for the reciprocal, it will be at minus 1 over 3, because that's minus 3 over 1. So minus 1/3, about there. So we know it's going to go through here. And then any key features. Here we can see that's the key feature of that turning point. And the turning point is minus 1, minus 4. Remember, we're only looking at the y value. If the y coordinate is minus 4, the reciprocal has to be minus 1/4, which is even closer to 0 than minus 1/3. I might just label this minus 1, minus 1/4. Alright, so that should be enough. This part here is really close to 0. 1 divided by something really small is really big. Okay, so we can graph that. Here, really small, really close to 0. So 1 divided by something really small is really big in a negative direction. Yep. And here also really small, 1 divided by something really small is really big. And that is it. All right. Question E. Sketch the graph of y equals 1 over f of x if f of x is equal to negative bracket x minus 2 squared, and find its domain and range. I just realized that I did not work out the domain and range for question D, so let me just go back up and let's have a look at this. So we can see here that the domain, which is all the x values, goes from negative infinity all the way to minus 3. Then there's a asymptote, so it needs to be curved bracket, union, from minus 3 to positive 1, where there's another vertical asymptote, so we're using curved brackets, union from 1 to infinity. Another way to write this is just x is not equal to minus 3 and x is not equal to 1. Okay, and the range, we can see here that it's always above 0, so y is greater than 0, but it's also less than minus 1/4 because that's the highest point of this one. Y is less than negative 1/4. Now if we were to write that in interval notation, then we would have negative infinity to negative 1/4, union 0 to infinity. Sorry, I just forgot. I just realized that that negative 1/4 should be a square bracket because we do include it. It does go up to minus 1/4. So we need to include that. So that means this one here has to be less than or equal to. Okay, so let's try E now. Maybe I'll get you to pause the video and have a go with this one yourself. Okay, so I've drawn here y equals f. I've drawn here f of x, which is equal to negative x minus 2 squared. We can see that the turning point is 2, 0 because we're going right to, or we're going not up or down because it's technically plus 0 here. So turning point is 2, 0, and the y-intercept is when x equals 0. When x equals 0, f of x is equal to minus 4. So I've graphed that. now I can graph y equals 1 over f of x. And so the first thing I need is when y is equal to 0. When y equals 0 is the x-intercepts. There's a vertical asymptote right here. Next one, when y is equal to plus minus 1. 1 minus 1, there's nothing for when y is equal to 1, but there are two places where y is equal to negative 1. Alright, the third thing is the y-intercept. Well, here we can see the y-intercept is, or the y-coordinate of the y-intercept is minus 4. So that means the reciprocal has to equal to negative 1 over 4. So negative 1/4, about there. That's my y-intercept. And any other key features. The only key feature here that we can see is the turning point, but the turning point is when y equals 0, and we've already dealt with that, so we don't need to worry about that. So now we can graph our reciprocal function. So here, really close to 0, something divided by 1 divided by anything really small is really big in a negative direction. Same with this bit here. 1 divided by something really small is really big in a negative direction. And so that should be enough. Let's graph this. Remember, we're never crossing the x-axis. Let's try that again. And that's it. That's y equals 1 over f of x. Alright, last one. Given that f of x is equal to x bracket x plus 1, x minus 2, sketch f of x to the minus 1 and find its domain and range. Oh, again, I forgot to do that. So let's quickly do that. The domain. We can see here that the domain is all the x values, so it goes from minus infinity all the way to 2, because that's where the vertical asymptote is, so I'm going to use a curved bracket. Union from 2 to infinity. And the range, well, the range goes from negative infinity, because it goes all the way down here, from negative infinity all the way up towards 0, but it will never ever touch 0, so it's going to be a curved bracket, and that's it. Okay, f. Right, let's have a look at f. So, come on, axes. We've got, here we can see the the x-intercepts is when y is equal to 0. So we've got 0, minus 1, and 2. 0, minus 1, and 2. They are our x-intercepts. Our y-intercept is when x is equal to 0, which we can see is just 0, because 0 times all of those will be 0. And that's pretty much it. Now we need to graph the shape. Now, when we expand this out, right, we've got x times x times x is x cubed, which we know is going to be this shape. So we know we're going to start down here, we're going to go up, and then back down, and then go back up. Right, it's going to look something like this. Now, we are not too sure, because we haven't learnt yet, exactly what the y values of these are, right? And it might not even be at when x is minus half and when x is 1, right? The turning points might not be there, but it's around there. And so what I'm going to do is I'm just going to estimate what the y values are by using these values of x equals minus half and 1 into the original. And that should help me just get a good idea of what it'll look like, even though it might not be like that exactly. So when x is equal to negative half, f of negative half, or y, because I'm just subbing that in. Let's put that in, negative half. So we've got that times that plus 1 times that minus 2, which is 5/8. Okay, so that's 5/8. which is less than 1. All right, and when x is equal to positive 1, f of 1 will equal to 1 times 2 times minus 1. Minus 2. Okay, so that's minus 2 here. All right, so now let's graph our reciprocal. We'll do it in green. First thing, the x-intercepts when y is equal to 0. We know that these are vertical asymptotes. Boom, boom, and boom. All right, second thing, when y is equal to plus minus 1. Now, 1 is more than 5 on 8, right? Let's just say that this is 1. So that means it will only go through this bit on the graph. And minus 1, we'll just say that this is minus 1 here. It means it'll go through here, here, and here. Okay, third thing, y-intercept. Well, the y-intercept is at 0, so we've already dealt with it with this one. Number 4, key features. Key features being turning points. Now here we can see that I'm assuming the turning point is around here. Okay, it might not be there exactly, but you know, halfway between these two x-intercepts should be roughly there. And so the reciprocal of 5 over 8 is 8 over 5, which is up here. Right, it's above 1. And this one here is got a y coordinate, a y value of minus 2, and the reciprocal of minus 2 is minus half. So when x is 1, it's going to be around there. And that should be enough for us to graph this reciprocal function. So 1 divided by something really small will be really big in a negative direction. So let's graph that. 1 divided by something really small is really big. 1 divided by something really small is really big. One divided by something really small is really big in a negative direction. Divided by really small is really big in a negative direction. And divided by something really small, really big. And that is what it looks like. Alright, so that's it for this video. I hope you found it helpful. If you did, please give it a like and subscribe. I would really appreciate that. Have an awesome day, and I'll see you in the next video. See you.